Hello everyone. Today I'll be taking your data structures. My name is Swati Tomar and we will start with the second unit of data structures, which is stacks. Okay. So I've already told you about ADT. What is in ADT? ADT is an abstract data type. Okay. So how do you know what is an abstract data type? What is an abstraction? Overall, abstraction is what is the kind of information which is hidden from the user, whose implementation is hidden from the user. For example, the user of data type, whoever is using the data type, the user does not need to know that how the data type is being implemented. For example, we only know the primitive values like int, float, char, but we don't know we don't have any knowledge regarding these data types, how they can be operated or how can they be performed with, and we do have no idea how are they going to be implemented. Okay, now I'm going to give you an example. What is an abstract data type? Suppose there are stacks, we'll study further, but suppose you know how an Android mobile works, right? But do you even know that how is an Android application is built and how is the developer developed the application? Is it possible? No. You just know, you just go to your go to a mobile shop and you just purchase your phone without having the knowledge of the working of the mobile. You know how to operate it, but whatever is going on the inside the your mobile, that knowledge is hidden from you. So that is what we call abstraction. Abstraction basically means that hiding, only showing the essential part and hiding the implementation part. Okay, so a user only needs to know what a data type can do, but not how it can be implemented. Think of ADT as in black box. What is in black box? Black box hides the inner structure and design of the data type. Okay, now we will be studying three different ADTs, which are list ADTs, stack ADTs and queue ADTs. See, I'll just zoom this out for you. So, what is in list ADT? The data is generally stored in key sequence in a list, which has a head structure. Okay, basically in a list ADT, whatever data it is going to be stored in a key sequence. There will be a head. You know, you have all have studied linked list. आप लोगों ने linked list पढ़ी है. Linked list का first part क्या होता है? Head. Okay. Now the head structure consists of count, pointers and addresses of compare function. Okay. The data node contains a pointer to a data structure and a self-referential pointer which points to the next node in the list. Now, what is a self-referential pointer? You know, the pointer which points to itself can be explained as the self-referential pointer. Now, these are the list ADT functions. Get. What does get do? Get returns an element. Now, these are the list ADT functions, means you will just add these functions in your program and you don't need to know how they will work, how they will, like, get is a function which returns the element from the list at any given position. You just need to get enter the index and it will give you the element from the list, right? But you don't need to put your logic here. You don't need to write your own logic. You just use you will just use this function and this will give you the value of the element present at the particular position. Now insert. Insert does what? Inserts an element at any position of the list. Remove, as you can already know by the name. Remove, what will remove do? Remove will just remove the first occurrence of any element from a non-empty list. Any कोई भी आपकी non-empty list है, okay, उसमें से remove क्या करेगा? Remove आपके element को remove करेगा या delete करेगा. Remove at. अब remove at क्या करेगा? Remove at क्या करेगा? specified location पे आपके element को remove करेगा. Replace will replace any element at any position by another element. Replace will, what will replace do? Replace will just remove an element present at any position, okay, by a different element. Size. Size will return the number of elements in the list. For example, there are 3 to 4 elements in your list. Size will return the number of elements present. Is empty will return true if the list is empty, otherwise it will return false. What will is full do? Is full will return true. Now, if we want to check if our list is empty or it is full, then is full function what will it do? It will return true if your list is full, otherwise it will return false. Stack ADT. Stack ADT आपका क्या करता है? We are just basically coming to stack. In stack ADT implementation, instead of data, okay, before coming to stack ADT, we should first know what is in stack. We will learn about it. This is a stack. Now, what is happening here? You can see it's like an array. There are number of slides, or you can say these are number of data plates. Okay. Now, this is in stack. What happens in a stack? What is a stack? Stack is a linear data structure which follows a particular order in which operations are performed. The order may be LIFO, last in first out, or first in last out. Now, let me make this clear to you by taking a more real life example. For example, while washing dishes, what you do, you just wash a plate and just put it there, and you take another plate, you wash it, then you place it above the plate already there, right? Now, like this, we keep on adding plates to the same stack, same heap. अब मैंने क्या किया? Basically मैंने क्या किया? मैंने प्लेट धोई, मैंने प्लेट टेबल पे रखी, right? उसके ऊपर मैंने एक और प्लेट वॉश करके उसी के ऊपर प्लेस की. Then third one will come above that second plate. Okay, so like this I will, like this is my first plate. Okay, then above this I place another plate, above this I placed another plate. Okay, so like this I will keep adding plates, है ना? Now, while these are the dishes which I washed, these are the washed plates. Now, when I want to use these plates, how will I take them out of the stack? One by one. This went first, right? This was my first plate. Then this was my second plate. This was my third plate. This was my fourth plate. This was my fifth plate. Now, when I want to use these plates, or when I want to like soak them with a cloth, what will I do? I will take out this plate out, right? I cannot I cannot just use this plate at the first position without removing all these plates. Okay. Let me explain it to you again. See, what I am trying to explain is, what is a stack? In a stack, whenever a data item or whenever a particular value comes, it comes in this pattern, right? Right, like this was my first plate, it was at my first position initially. So I can also index it by 1. Here I am using 0 to use my indexing. Then this came secondly. This will be my first plate, first index, sorry. This will be my second index. This will be index for my fourth plate. This will be index for my fifth plate. Okay. Now, when I want to remove these plates, how will I remove them? One by one. Okay. So, first of all, I will take this one out. Then I will take this one out. Then I will take this one out. See? So, that is why stack follows what? Stack follows linear last in, first out. The last one to be come inside will be the first one to be out. Okay. Or we can also say that the stack follows the pattern of philo, or first in, last out. The first plate to go inside the stack will be the last one to come outside the stack. Okay. There are other real life examples also of stack. The plate example I already gave it to you. And what you understood that that the plate which was at the top was the first one to be removed, okay, and the plate which had been placed first was the last one to be removed, right? So stack is what? Stack is basically last in first out data structure. The stack is used in different area for evaluating expressions, call and recursion strategy. Stack आपको कहाँ use होता है? Stack आपका expressions को evaluate करने के लिए use होगा. We will study about postfix and prefix in the next lecture. Then I will teach you how the stack is helpful in evaluating expressions. Stack can be used in calls and recursions. The stack has some primitive operations, and those primitive operations are the one which we saw in ADT. Now let's go back to stack ADT. Now you all are already aware of what is a stack. See, okay. Now we will learn about what is stack ADT. Coming back to the previous slide. Okay, this was a stack ADT. In stack ADT implementation, instead of data being stored in each node, the pointer to data is stored. Okay. What does this mean? Whenever stack ADT implementation is done, the data is not being stored in each node, but the pointer to the data is stored in each node. Okay. The program allocates memory for the data and address is passed to the stack ADT. What happens in stack ADT? The program will allocate the memory, whatever memory is required for the data, and then the address will be passed to the stack ADT. The head node and the data nodes are encapsulated in ADT. The calling function can only see the pointer to the stack. What does the head node do? The head node and the data node, they will be encapsulated in your ADT. What is an encapsulation? I already told you. Encapsulation means hiding the information. Encapsulating means storing the information, encapsulating the information, essential information. Okay. The head node and the data nodes will be encapsulated in the ADT. The calling function can only see the pointer to the stack. The stack head structure also contains a pointer to top and count of number of entries currently in stack. What does the stack head structure contains? The stack head structure contains a pointer. It will contain a pointer to the top and count of number of entries currently in stack. Okay. Now these will be the stack ADT's functions. Push. What will push do? This one is very important. What will push do? Here, push will be playing the role of inserting an element at one end of the stack. And one thing more, suppose this is my stack. These are my elements present in the stack. This is my index. These are my stack elements. This element present at the topmost position is called the top of this stack. Understood? So this is what? The top of the stack. And whenever an insertion is to be done at the stack, what will we do? Where will the element be inserted in the stack? At above this position. Suppose this is this stack is full right now. Now there is position for another element here, but top is still 4. Okay. Top denotes what? Index of the last element or the topmost element present in the stack. That is what top indicates. So here top is 4. This is my top. Okay. Now, when I want to do the insertion at this particular stack, what will I do? Where will the element come from? It will be done at here. Now, where will my top point to right now? The top will be pointing to here. Now, this will be my new top. Understood? So, this is my top and this is my stack. One thing more, another thing that you should learn, you should know that insertion in a stack can be done at one position only. Okay. Insertion will be done here and deletion will also be done from this part only. Insertion and deletion are done from the topmost part of the stack. So, insertion is called push in a stack and deletion is called pop. Now, what does pop do? Pop removes and returns the element at the top of the stack if it is not empty. Whenever we want to proceed with deletion in any data structure, what is the first step we take? What we do is we check if the element to be deleted, if the stack is empty or not. And that condition is called as underflow. Suppose this is my stack and I want to delete an element present at position 4. Is it possible to delete an element from this stack? No. Why is it not possible? Because this is an empty stack. How can you delete an element from an empty stack? And this condition is known as underflow. What do we call it? Underflow. Okay. So this is, I explained how is deletion done in a stack, right? Now let's complete again, refill the stack. So what will push do? Push will do insertion in the stack. What will pop do? Pop will remove the stack. One thing more, whenever I delete, suppose I've deleted this element from the stack. Now where is my top pointing? The top also needs to be updated. Right now it was at 5, but since I have deleted this element, my new top will be 4. Okay. Now peak. What does peak do? Peak returns the element at the top of the stack without removing it if the stack is not empty. Peak क्या करेगा आपका? आपने इधर से stack देखा, आपको पता करना है कि थर्ड पोजीशन पे, थर्ड इंडेक्स पे आपके कौन सा एलिमेंट प्रेजेंट है. कैसे पता चलेगा? आप पीक फंक्शन यूज करेंगे और इंडेक्स का नंबर डालेंगे. सपोज थर्ड पे मुझे पता करना है, तो पीक विल रिटर्न यू डी. It will not remove it. It will just return you the element present at third index, which is D. Size. What does size do? Size returns the number of elements in the stack. Okay. What will size do? Size will return, suppose what will size return in this case? In this case, the size will return the size of the stack, which is 5. Is empty. Now, what does is empty do? Is empty will return true if the stack is empty. Otherwise, it will return false. In this case, this is empty function will return false. Okay. Coming to the next slide. Is full. Is full function, what is the role of is full function? Is full returns true. We will also need to check if the stack is full. So is full will return true if the stack is full, otherwise it will return false. Now coming to QADT, the Q abstract data type follows the basic design of the stack abstract data type. This is why I told you that you need to know what is a stack first. Only then you can proceed with QADT. What does QADT? Simply follows the design of the stack ADT. Each node contains a void pointer to the data and the link pointer to the next node in the queue. Each node in the QADT will contain a void pointer to the data and the link pointer to the next node in the queue. Okay, the program's responsibility is to allocate memory for storing the data. These are some of the functions of QADT. NQ, what will NQ do? NQ will insert an element at the end of the queue. DQ will remove and return the first element of the queue if the queue is not empty. Peek, like in stack, what did peek do? Peek returned the element of the queue without removing it, and the same function it will be going to performing here. Peek here will return the element of the queue without removing it. It will not remove the element, it will just simply tell you that at this particular index, this element is present. Then size. What does size return? Size returns the number of elements in the queue. Empty. What is empty? It is empty. Again, it will return a Boolean value true if queue is empty. Otherwise, it will return false. Is full will return true if the queue is full. Otherwise, it will return false. Now, what are the features of ADT? Why do we particularly use ADTs? These are three main important features of ADTs, which is abstraction. Again, I told you from the starting of the lecture, what is an abstraction? The user does not need to know the implementation of data structure. Okay. In ADT, the user does not need to know how the data structure is being implemented. Better conceptualization. ADT gives us a better conceptualization of the real world. ADT's abstract data types give us a better conceptualization. Robust, the program is robust and has the ability to catch errors. From these definitions, we can clearly see that the definitions do not specify how these ADTs will be represented and how the operations will be carried out. There can be different ways to implement an ADT. For example, the list ADT can be implemented using arrays. Okay, coming back to implementation part. For now, we just learned about what are ADTs, what are the types of ADTs and what is a stack. You already know about linked list ADTs. I told you in the last lecture in the first unit. Now, what will we proceed with now? The implementation part of stack. Stack can be, how is stack implemented in the memory? Stack will be implemented by, can be implemented using arrays or linked list. Okay. So the stack is what? Coming back to stack, our main important topic for this lecture. Stack is last in first out data structure. The stack is used in different areas for evaluating expression. I already told you. Call and recursion strategy. The stack has some primitive operations. Here we see those operations of stack and see one example using the stack ADT. What type of pattern or what type of data structure is stack? It is last in first out. Why? The last element to go inside the stack will be the first one to be coming in outside. Where is stack used? What are its applications? Stack can be used in different, like for evaluating expressions, calls and recursions. What is ADT? The ADT or abstract data type is a special kind of data type. I'm just doing a quick revision for you. The ADT is a special kind of data type whose behavior is defined by a set of values and set of operations. The keyword abstract is used as we can use these data types. We can perform different operations, but how those operations are working, that is totally hidden from the user. What again? Here you can see abstract. What does abstract stand for? Abstract means that we know what to use whenever it is needed, but we don't know how it is going to be implemented. The implementation part is hidden from the user. So these type of data types are what abstract data types, right? Now the ADT is made of primitive data types, but operation logics are hidden. जो भी ADTs होते हैं वो आपके primitive data type से बने होते हैं, right? But जो operation का logic होता है वो hidden होता है. These are few operations और फंक्शन ऑफ स्टैक एडिटी ये हमने अभी पढ़ा था, इज फुल क्या चेक करेगा कि स्टैक फुल है या नहीं, ट्रू या फॉल्स रिमूव करेगा उस बेसिस पे। इज एम्प्टी चेक करेगा कि स्टैक एम्प्टी है या नहीं, एंड ऑन दैट कंडीशन इट विल रिटर्न यू द वैल्यू ऑफ ट्रू और फॉल्स। सिमिलरली पुश क्या करेगा, पुश विल इंसर्ट एलिमेंट इनटू द स्टैक। पॉप क्या करेगा, पॉप विल डिलीट one element from the top of the stack. I already told you deletion happens from the top and insertion also happens from the top. So pop is used to delete one element. Pop function will delete one element from the top of the stack. Peek will help you to get the topmost element of the stack. What will size do? Size is the function which is used to get the number of elements present in the stack. Now this is your stack. You can see when this is my top. Whenever I want to add an element or push an item into the stack, it will happen from this part. And when I want to delete an element or pop this element, what will I do? I will just simply pop an element item from the frontmost part, which is top. I will remove this element from the top part. Okay. So in the next lecture, I'll just tell you a little bit about algorithm of push. How is push or insertion done? What does push do? Push adds an item to the stack. If the stack is full, then it is said to be an overflow condition. You should all know by now that what is overflow. Suppose this is my stack and there are elements present here. 1, 2, 3, 4, 5. Okay. Now I am pushing an element 6 here. Can I insert an element in this completely full stack? Is it possible? No, it's not, because this stack is already full. For that, I will use the condition overflow. My first step will be to check if the stack has any space for insertion or not. So what happens in an overflow condition? I will just check if the stack is full. If it is not full, then I will return that overflow. Okay. If that is not the case, now let's continue with the algorithm. If stack is full, return and if. Your if loop will end here when the stack is full. Else, suppose this is not the case and there is a space in this stack. What will happen then? Increment top. Initially my top will be this. Initially my top was this. Let's say that my top was pointing here. This is my indexing 0, 1, 2, 3. Suppose my top was pointing here. Now I inserted this element 6 here. Insertion has been done. So what will my step will be? To increment top. Now my top will be, my top was 3. Now my top is 3 plus 1, which is 4. Okay. Now stack top को हमें क्या करना है, स्टैक के टॉप को वैल्यू असाइन करनी है, फिर एल्स लूप आपका एंड हो जाएगा और प्रोसीजर एंड हो जाएगा. नाउ स्टैक टॉप इज, टॉप क्या है आपका 4 एंड यहाँ पे जो वैल्यू है आपकी वो इंसर्ट हो जाएगी. सो दिस इज हाउ माय इंसर्शन इज बीइंग डन. Before ending this lecture, I'll just give you a quick introduction to POP. What happens in POP? What does POP basically does? POP basically removes an item from the stack. The items are popped in the reverse order in which they are pushed. If the stack is empty, then it is said to be an underflow condition. Now what does this statement mean? The insertion was done in this manner. First 5 came, then 4 came, then 3 came, then second 2 came, then 6 came. Now how is insertion will be done? Insertion will be done in the opposite or reverse order. First 6 will be, deletion will be done in the reverse order. Now the first element to be deleted here will be 6. this will be the my element which will be deleted. Okay. And the next element to be deleted will be this one, then this one. So what I am trying to tell you here is that the insertion will be done in this manner and the deletion will be done in this manner. Okay. So how is deletion done? First we will check if the stack is empty, if the element to be deleted is at least present in the stack. If this is my stack, now this is an empty stack, deletion is not possible in this stack. Why? Because there is no element present to be deleted. Okay. In this case, when there is no element in the stack and we want to perform deletion, so this condition is called underflow condition. If stack is empty, return, else, suppose this is not the case, this is my stack 8, 9, 10. This is my topmost element. Okay. So what I will do here is I will decrement the value of top. My top will be pointing at 1 now. Previously it was pointing here. So my new top is 1. Okay. Now this is my new top. And then what will I do? I will delete or remove this value present at the previous top. So store value of stack top, decrement top, and return value end else. Else loop will end here, and then this complete procedure will end at this step. So today we've learned what are ADTs, what is a stack, what are the different kind of functions performed in different ADTs, what is push operation, what is pop. In the next lecture we will learn many more algorithms related to these part only. Okay, that will be all for today, and this is the end of the lecture. Thank you.